Kohir. So I welcome Dr. Kohir sir on the
Good
behalf
evening to
of
everyone.
Sri Siddheshwar Women's College of Engineering, and and also welcome to all the participants. Good evening all. I will take the privilege to welcome Dr. Vishaldatt Kohir, a distinguished academician with 35 years of rich experience in teaching at the graduate level. Dr. Kohir is currently serving as a professor in the Faculty of Engineering and Technology at Khwaja Bande Nawaz University, Kalburgi, Karnataka. Dr. Kohir has made significant contribution during his illustrious career. He previously served as an associate professor at Angadi Institute of Technology and as the principal at VSM Institute of Technology, Nipani, Maharashtra. I hope Nipani, Karnataka. A gold medalist in MTech from VTU, Belgavi, Dr. Kohir has published 20 research papers with 31 citations. His exemplary work has also earned him the honor of guiding two PhD scholars to successful completion. His special achievements include delivering 35 invited talks, serving as a session chairman at 4 conferences, coordinating NAC accreditation process, and mentoring 5 academic events. Beyond academia, he runs an engaging YouTube channel with over 1,200 subscribers and has organized 25 quizzes for school students to inspire young minds. We are grateful for the opportunity to learn from Dr. Kohir's vast experience and expertise and innovative perspectives. Let us welcome him with a great enthusiasm. Welcome, sir, once again, and thank you for accepting our invitation. And I request you to start your session, sir.
Thank you. Thank you very much and good evening to one and all.
I will
Can
stop
I
my
share my screen?
yeah. I will stop my presentation.
Yes.
You can share now, sir.
So now my screen is visible?
Yes, sir. It is visible now.
Yes. Good evening to one and all.
Good evening, sir.
Good evening. So at the outset, I would like to thank the organizer of 6 days online FDP sponsored by AICT and ATAL FDP. So nowadays, the composite materials are the not new to the engineering teachers or the engineers. So everybody is familiar with the what we call it as a composite materials. The topic which has come to me or it has been assigned to me is fabrication of metal matrix composites, pros and cons. I think in this meeting there may be so many people who will be what you call already might have worked on this or some may be still working on it. Rather than calling it as an FDP, I wanted to have a good interaction or a good discussion uh, on what you call pros and cons of our uh, fabrication of metal matrix. One second, let me put off my WhatsApp this one. I'm audible, participants.
Yes,
Hello?
sir. Yes, sir.
Yes, sir,
Yes.
you are audible, sir.
Yes, yes. Because I won't get any feedback, no? That will be.
Sir, the participants' mics are actually mute. That's why they.
Yes, yes, yes.
Yes.
We will allow
One
them at
second.
the time of question answer, sir.
Yes, yes, yes. Any feedback, anything, you keep on giving it me so that I will get an idea whether my screen is visible to everyone or not. Okay.
Yes, yes, sir. The chat box is also open, sir. They
Uh,
can ask the questions from
that's
chat
yes,
box.
yes, yes. Right now, I am
Yes, sir.
going with a full screen, but I am not
Yes.
getting the any chat box or anything. So that
Oh,
I think I need to change the layout. I think change the layout. Auto tiled. Okay, I think something. Okay, now my presentation is visible.
Yes, sir. Yes.
Yes. Okay, so let me start with this one. So today's agenda, what I planned is, so as usual with introduction and metal matrix composite, then fabrication part, then comparison of various fabrication methods, challenges and limitations, then solution to major challenges, then some case studies, and finally, what are the pros and cons of fabrication of metal matrix. As an engineer, always uh, we look for three things. In my opinion, in as a basically as a mechanical engineer, we look for three things: speed, cost, and quality. So every engineer strive to do the same thing. He wanted to produce the product as quickly as possible, as cheap as possible, and as good as possible. Okay, when small feedback on visibility of my screen. Is it visible?
Yes, sir. Yes, it's clearly visible, sir, on
It
full
is
screen mode.
clearly visible. I am also
Yes, yes,
clearly
yes,
audible
yes,
to one and all.
yes, yes, yes.
I think being an engineer, always we do this one. Of course, when we say engineer, we say that one he should design, he should do it. But basic target of an engineer is always to produce the products at a cheaper cost, at a better quality, and at a faster rate. But in changed scenario in 21st century, engineers aim is to develop the things for the sustainability. So what I say, a sustainable engineering is a way of designing, creating things that meet our needs without harming the environment or depleting the natural resources. I hope everybody agree with me this one. Now the buzzword is the sustainability. Whether it is a energy area, whether it is a manufacturing area, any area you take it, even you talk about the natural resources, everybody talks about the sustainability. In this perspective of sustainability, the pros cons of fabrication of metal matrices becomes little more special. So I congratulate the organizers for selecting this particular topic for the FDP. As an engineer, always we look for these three things. That is, any engineer is, especially when we talk about a mechanical engineer, always we strive to do some better product. And when we talk about a product, always we talk about its performance. What do you mean by the performance? It should give the sufficient service at a service station or at a service place without failure. So whatever the conditions are there, whatever the requirement of the service conditions are there, whatever the requirement of the product is there, so it should perform well. Perform means it all together. Quality, its reliability, its durability, all together I'm calling it as a performance of a product. Basically, any what you call performance of a product is dependent on the property. Okay, I think everybody will agree with this. Okay, so any performance is quite related with the property. Is it not? If you wanted to have a better performance, definitely I should select a material which has got a suitable property for us. A very common and very simple example is that of a gold. So we make use of a gold. We use the gold for jewelries and wearing it on a what you call human body because it's a noble metal. If you wear any other metal, it will react with the body and it will harm the human beings. So what comes to the performance is the property of a material. And how this property of the material is decided? Of course, we have got a variety of different properties. I would like to know from the participants what are the general properties we talk with respect to the materials. Just a small interaction with the participants. So as an engineer, we look for which properties, or rather, what are the different properties an engineer try to deal it. Can I get feedback from what I call participants?
Participants can unmute their mic and can directly interact with the sir.
Strength,
Tensile strength, compressive strength.
Okay, these all put together, I can put it in one word: mechanical properties. I'm right?
yes.
Yes. Any other property?
Thermal properties,
Fantastic. Thermal property, we can accept it. Any other property?
Sir, there could be physical, mechanical, chemical.
Yes, you are absolutely right. Physical
Yes.
property, chemical property, magnetic property, optical property.
Right.
Okay, so there's a series of properties are there. Okay, as a mechanical engineer, always we are interested in mechanical properties, but this property is dependent on its structure. Property is dependent on the structure. The structure, it may be, again, there are variety of structures are there. It may be macro structure, it may be microstructure, it may be crystal structure, it may be electronic structure. But as a mechanical engineer, always we are interested in microstructure or the crystal structure. So any change in the structure will lead to the changes in the property. A small example I can take, and I want again one small answer from the participants. The graphite and carbon are made up of from the same material. Can anyone name which is the material? Graphite and diamond.
Is it carbon, sir?
Yeah, it's absolutely right. It is made up of a carbon. See, the material is carbon. When we deal with graphite, it is very what you call malleable, and we use it for writing on a pencil or something like that. We do it. The same carbon in the form of a what you call diamond, it will become hardest material in the what you call available. Among the available material, it will become the hardest material. So what makes it the difference? The structure, the arrangement of the carbon atoms in graphite and arrangement of carbon atoms in diamond makes a change in the property. So the structure of a property is very, very important for us. So performance dependent on the properties, and property is dependent on the what you call structure. And what kind of structure I got it depends upon the processing. How I process it, that will decide the what you call my structure. So most of the time we are very much interested in, especially when I talk about the structure, I'll be talking about the microstructure. Okay. Can anyone give me an idea what do you mean by a microstructure? Apart from it is visible in through microscope. Apart from this definition, I want any explanation for the microstructure. So what do you mean by microstructure? So participants, if you give, that's what I say that we are all I think we are all the teachers. We are all teaching the subjects regularly in our academic classes. So interaction is always very important one. Sometimes I may learn something from you, you may learn something from me. So let's make it little interactive and let it be more discussion type rather than what you call a monotonous type. The basic objective of faculty development program is that we all faculty together make some changes in teaching and learning process. That is the main aim. Okay. So with this note, I again reaching out to the my what you call participants. Can anyone tell me what do you mean by a microstructure?
Large in size.
It can't be. When I call it as a micro, it has to be small
Micro,
in size.
small in size. Sorry, macro and micro.
Macro,
Small
yes,
in
yes,
size.
you are right. You are right. Macro is large. Micro is a smaller one. Yes. See, any answer you can give it. Okay, there is no restriction because it's an interaction. It's not checking off any what you call. See, what happens is, as a teachers, our aim is not to define the things. Our objective is to what you call conceptualize the things and convince the students about it. We have to teach them at a conceptual level, no? So when we try to reach them at conceptual level happens, everybody's way of expressing the thing will be different one. Okay, well, I'm not getting much this one. A last chance, I will take it. Any answer?
Sir, in the chat box, there are some answers like surface topography. After that,
Okay.
phases present in the alloys, arrangement of grains.
Okay. These phases, the chart box will not be visible to me. How to make that one visible?
Actually, it should reflect in the during the presentation right corner.
Okay, but probably I have gone with a what you call full screen. Probably I may not be getting that one. I think. Let me check that one. If possible, can I get that one? I will
Sir,
try to change it once. Once.
while sharing, just share the window, sir, not at the entire screen.
Okay, that one I will do. Okay, so that I travel. That's one suggestion has come. Okay. I'm sharing the window. But when I share the window, I think again I'm getting full. Okay, let it be. Okay, we will go with the chat box. The answer which has given different phases, something is there, no? Organizer?
Phases present in alloys. This is
Yes.
one answer.
And one more is what?
Arrangement of grains.
Arrangement of grays. Okay, these are the very close one. So
And
basically, different phases, distribution of different phases itself, we call it as a microstructure. So why I'm asking this question is that when we go for the fabrication, this microstructure is going to decide the my properties. Some connection is there between obtaining the structure with the properties. So that's what I thought that one. So better to have an idea before we get into the fabrication of what we call structures. Okay. So in this way, there is a connection is there between performance to the properties, properties to the structure, and structure to the processing. So our topic is what we call it as a fabrication of metal matrix. I wanted to have a look at these two statements. Material scientist studies materials and create new materials. Material engineers use materials and create new forces, new processes. Just I wanted to give you an idea what is the component, what do you meant by composite in my own perspective. Normally I made this a small video for my own students. I hope that one you will also like the idea of convincing why we need these composites. Okay. I think this is what I try to tell you that why we need to have a composite material. Okay, there are two ways of achieving the changes in property because the performance is dependent on the property is dependent on the structure. So we need to change the structure. So we need to have a combination of the material so that I can try to get the required properties to have a better performance. So what happens in alloy is that one when you mix up the things, so you will have a interaction or a reaction between them and it will altogether a different property of a or B. It may not be true always, but in simplicity we can think like this to get the what you call why we need a composite material. So whereas composite material will give you the best of the A as well as the best of the B. So in order to get the best of everything, so it is better we go for what you call composite materials. So this is a small definition or definitely small understanding of composite materials from my side. And we know that one in composite material, there are three components are there. So one we call it as a fiber or the reinforcement. Another one is matrix material. So everybody knows that one. Matrix and fiber, both together. Oh, sorry, matrix and reinforcement material, both are going together to form the composite material. I think from 3 days you might be listening to this one. There are, in my opinion, there are 4 reasons are there why we should go for the composite material, and these are the very common reasons. The first one is composites have a high strength to weight ratio. Okay, so this is the major what you call reason why we go for what we call it as a composite material. So when you strength to weight ratio is there, so you can find 25% as much as steel, 70% as aluminum. Just I'm underlining it. So this is showing you that one. So how much advantage we are having when it comes to the strength to the weight ratio. So this is the reason why we go for the composite material. The second thing is what we call it as a durability. Okay, the composites never rust regardless of environment. This is one of the, so very, when we started the study of material, we always start with a ferrous material and non-ferrous material. And when we talk about the non-ferrous material, the very first reason we say that one, we go for the non-ferrous material because it is corrosive resistance and wear resistance. So my composite materials are much more than the non-ferrous materials. So they never rust it, and they are good at all the environments. So these are the reasons. Even what you call these composite materials are what you call less fracture toughness. Okay, so these are the reasons why we go for the composite materials. The third one is composites are open to new design options. So this is one of the things, important things. In conventional material, we don't have much flexibility to do anything new design in the materials. Whereas in composite materials, we can have a tailor-made properties, or you can
Sir,
have a
sir, may I interrupt?
yeah,
Slides
yeah,
are not
sure.
changing. If you are changing the
Slides are
slides, but not changing the, I think fourth slide is only visible now.
okay. With 4 reasons why this is visible or not.
Fourth slide, there is 1, 2, 3, 4 processing structure, properties, performance.
Okay, still it is there only. That only is there.
Yeah. Yes, sir.
Oh, okay. Let me check the thing.
Yeah, now it is changed. One, fifth one. I think it is sixth one.
Sixth one. Now it's visible.
Sixth one is visible, but in small scale, means not in the PPT mode.
Okay. Okay. I think I will go with the full sharing option. So that will be
Yes,
better,
sir.
I
Yes.
think. Again, window. Now it's visible.
Make it full screen, sir.
Now,
No. So earlier one, whatever you started, no,
yes. Okay.
that is
Just
better. Only the
yes,
chart
yes.
was not coming,
Right.
so that we will inform.
Yes. Yes. So entire screen will be always better. There won't be any what you call. Now I think it's visible.
Yes, yes, sir. Now it is entire
Four,
screen and
okay, 4 reasons
four.
are replacing traditional materials.
Yes, sir. Yes, that is there.
Okay, I wanted to try with another one, but it will create some noise, I think. One more time, I will try to do this one. So let's allow me, I'm logging. Some echo, it will start taking place.
This is okay now, sir.
Now it's visible?
Yes, sir. Yes, it is visible now and full
Yes.
full screen.
No, full screen visible it is?
Yes, sir. Yes.
Okay. Number
Continue,
one
sir.
is, yes, composites have echo. Anything is there?
No, sir.
My
No.
audio is clear, no?
Yes, yes. No echo, nothing else. It is good.
Yes. Okay. So there are four reasons. Two I have discussed, and third one I was in process of explaining. That is, composites are open for new design options. Okay. So one, they have got a high strength ratio. Second one, they are more durable, and the fourth one is composites are now easier to produce. This is one point to be noted nowadays. Okay, so almost all areas of what you call life, the composites are what you call we are using it. Again, I would like to go back to the audience and wanted to get day-to-day using uh, objects or the products which are made out of the composite, not necessarily metal matrix. Let it be any composite material. Uh, can I get examples of use of composite in day-to-day life? Just I'm going to the audience.
Good evening, sir. Hello.
Pardon?
Good evening, sir.
Good evening.
Yes, sir. We use composite materials in day-to-day life. For example, wristwatches, shoes, even mobiles.
It a little
Even
bit
pens.
more. Okay, I wanted to little more specific. You are right. You are absolutely right. There is no doubt about it. Okay, Sachin Bhosle is
FRP
selling
sheet.
sports equipments like badminton racket, bicycle frame.
Yeah.
Fantastic. Yes. Any other?
FRP sheets, sir.
Yeah, for species. Hey, our two-wheeler covers are there, no?
Body.
Our two-wheeler covers are there, car doors are there, car interiors are there. Okay, my spect, which is I'm using, spect is the best example. Okay. So somebody says that one beds. Okay, I'm not aware of the using of composites. Of course, with Kohir and spring, it may be a composite one. Okay. So fantastic. Thank you, audience, for being interactive. In my opinion, nearly 60% of the day-to-day life products, what we are using day-to-day life, it is all composites. Okay, so it may be plastic glass, it may be fiber glass, oven, what you call utensil which are so suitable for micro oven. All these things, there is no area where these composites are not reached. So this is the my what you call focus. I wanted to convey this message. Just look around you. Everywhere you will find the what you call, right from a hanger, pin, whatever you take it, any product you take it, it will be a composite material. Rarely we nowadays find any any material which is made out of a conventional one. This is my idea. So little further we go, we more focus on what you call metal matrix material, and most of them are we will fill with 600 series and 700,000 series. This slide I will commit afterwards. And this is a what you call chart. It doesn't require much any idea, classification of what you call composite material, based on matrix material, based on reinforcement material. So we have a classification on what we call it as a composites. And this is a slide which is showing you that which materials we use as a matrix material in polymer matrix, in metal matrix, and ceramic matrix. My focus is on what you call matrix. So always I will be looking at what we call it as these metals: aluminium, titanium, and magnesium. Okay, when we go to the 600 series, 6000 or 7000, we will find what you call, along with aluminum, silicon, and what you call magnesium is added, and those are becoming more popular matrix materials. But basically, we use aluminum or aluminum alloys as the matrix material. In reinforcement material, silicon carbide is there, alumina is there, what you call boron carbide is there. Even people are going with hybrid composites. I hope that one every participant will be having some idea about these things. Just it's a refreshing things. लोहा मारने से पहले थोड़ा गर्म करना पड़ता है. So just I am preparing you for the what you call a topic on or fabrication on what we call it as a metal matrix. So basically my area or my focus will be on aluminum. When we talk about the metal matrix, most of the idea or most of the this will be there. 6000 series is basically magnesium silicate series, and 7000 series basically with zinc is there. And most of the participants might have got their PhDs on these series, or some may be still pursuing it, some may be working on it. But nowadays popular series are 6000 series and the 7000 series. So these are the various methods. Again, a classification of what we call it as how we can make a metal matrix process. So there are three varieties are there. So one we call it as a casting method. Another one we call it as a infiltration methods. Another one we call it as a solid fabrication methods. There are variety are there. Stir casting is the very popular. Then the squeeze casting is there. Then vacuum die is there, centrifugal casting is there, Rio casting is there, and Campo casting is there. So when it comes to the infiltration, so it is pressure infiltration, vacuum, gas, high pressure, ultra infiltration, liquid, So there are what you call, some are very popular, some are yet to be popularized. But again, in solid, powder metallurgy is the most popular one, and diffusion bonding is also there. And nowadays, people are using even this what we call it as a friction welding technique. That is, friction stir technique is also been used to make out what we call it as a matrix material. So basically, when we talk about a matrix material, so most of the time, okay, so most popular is the what we call it as a shear casting method. Okay, shear casting method is nothing but what we call it as a adding of our reinforcement material into the molten state matrix material. Okay, there are a variety of things are there through which we can do it. A small sketch is there, and most of the people may be aware of it. So there is a steering mechanism is there. So this is a crucible, you can say, you can call it as a oven, where I am going to make this what we call it as a molten metal, and most of the time it will be a aluminum. This is a molten aluminum method. So in this molten aluminum method, I am going to add what my reinforcement material. So it may be anything. Okay. So in this way, we can have what we call a making of a composite material. I talked about the microstructure. When we have a better microstructure, we have a better properties. Hence, my performance will be better. So for that purpose, the distribution of phases or the distribution of reinforcement material inside the matrix material become very important. So how things are distributed, how grains are formed, so which is going to decide the structure, that is going to decide the properties, that is going to decide by my performance. So some issues what issues or what challenges we face in the stair casting, we see it in coming slides. What challenges are there? How we are going to overcome the things. So this we discuss it little bit later. Okay. So I think I could able to give you an idea that even how a metal matrix is prepared using the steer casting processes. Okay, so one side I'm showing you the video just for enhancement of the understanding. Another side I'm showing you the sketch. There are different kinds of setups are there. Normally in experimental setup, what happens? There will be crucible will be there, and below that only we will have a what you call a die which has been attached to that, so that easily we can tap out the aluminum composite material and pour it into the die, and we can get the what you call a ingot of composite materials. So this is how what we call it as a metal matrix material is prepared with the help of what we call it as a steer casting. I hope that I succeeded in convincing the message on steer casting. I'm right, participants? You got good idea? Yes. Okay, Sachin Bhosle says yes. This is the only way by which we can, because unless and until we have an interaction, it's difficult for me to get an impression that people are watching it or they're taking the advantage of the FTP. Okay, so anyhow, we move it further. We go to the next slide. So this is a what we call it as a squeeze casting message is there. Again, let me mute the what you call this thing. So in squeeze casting, what happens? It is also a variety of what you call your casting process. Again, molten metal is there, and what you call pouring of the reinforcement material is there. There are different varieties are there in squeeze casting. So in some what you call squeeze casting processes, we use what we call it as a preformers. So this is what we've been shown here. We have a preformer of reinforcement material. Later we put the what we call it as a molten metal, and again we press it. In simple terms, squeeze casting is nothing but solidification under the what you call pressure. And there is a lot of differences in properties takes place when we compare to the shear casting. I'm very happy to share with you that a very successful research work is carried out by Santosh Madki using this squeeze casting process. If possible, we will have a small interaction with the Santosh Madki to understand that what challenges he faced while during the squeeze casting processes and how he overcome it. So probably at the end of the my presentation, we go for it. This is another very popular what you call way of doing it. Another very popular way of making the metal composite is the powder metallurgy. The biggest advantage of the powder metallurgy is that one, it will save nearly 50 to 60% of the raw material, because almost wastage is zero. When it comes to the steer casting, when it comes to the squeeze casting, you might have seen when we deal with the steer casting, when we carry the material in crucibles or in the when it is melting out in the furnace itself, leakages or wastage are there. But whereas far as powder metallurgy is concerned, very minimal what you call wastage of the materials is there. And biggest advantage with the powder metallurgy is that the very proper distribution of reinforcement material in the matrix material. When we deal with this, most of the metal matrix material, it will be particulate type of the matrix material. Rarely we deal with what you call fiber type or the discontinued type, but basically we deal with particulate type of the what you call composite material. Because the metal matrix and the reinforced metal, it may be metal or it's a non-metal, they are all in the powder form. Powder form means in the small grain forms. So definitely the good blending will be there, good compactation will be there. Apart from good compactation, the binding between the reinforcement material with the matrix material is better in powder metallurgy compared to the steer casting or the squeeze casting. So because of one phenomena, what we call it as a sintering one. So because sintering normally done at 60 to 70% of the metal, what you call melting temperature, this sintering, sorry, not steering. Sintering process will ensure what we call it as a proper binding between the reinforcement material with the matrix material. Normally, we call it as an interface. The binding between the matrix and the what you call reinforcement material, we call it as an interface. So interface will also play a very important role. So there are other methods are there. Diffusion method is there. So with the help of diffusion method also we can go for what you call making of matrix materials. Okay. So I think everybody is quite familiarization with carburization method. Is it not? Compact carburization, solid carburization process we will be knowing. It comes under heat treatment and other things. So the main principle behind is the diffusion of the material. So from higher concentration to the lower concentration, using our fixed law 1, 2, what we talk about it, but it's a slow process. But the advantage is that it is happening at an interatomic level. That is the biggest advantage with the diffusion. So another another what you call popular method is what we call it as a fray forming process. Okay. So this is also very easy and very what you call easy method. So normally we have a net of fibers or the reinforced material. Over that we keep on spraying the what you call spraying this our matrix material. So this is another what you call way of making the metal matrix. The diagram which has been shown here is you can see that one atomized droplets are there. Okay, this is the substrate is there. On that we keep on depositing it. In this way, we try to have a distribution of particulate type of the reinforcement material in the matrix composite. Remember, most of the time when I talk about the metal matrix, I will be dealing with the aluminum with a reinforcement of a silicon carbide or aluminum oxide, or it may be a boron carbide or silicon carbide. This is a small diagram which has been shows that one. To surprise me when I see this one, it shows that one 30% is done with powder metallurgy. So in aerospace industries and other advanced industries, most of the composite nowadays they are made with the powder metallurgy. Whereas my stair casting is very popular among our research persons. Why it is so popular, we will see it in the coming what you call the slides. So this is a squeeze casting is again it is gaining a popularity of around 22% is there. Okay, so this is the breakup of what we call it as a various methods. Apart from conventional and popular methods, there are another what you call methods are also are there, such as physical vapor deposition, chemical vapor deposition, electroplating, spray deposition. Just I discussed it. So this is a breakup, or this is an idea that how various fabrication processes are being used in present scenario. So this is a what you call a comparison. I am wanted to make it between what we call it as a stair casting, squeeze casting, compo casting, and in-situ and press casting. So this is by comparison based on what? It is on the cost effectiveness and application and comments on this. So least expensive, medium, low, expensive, and medium. So suitable for mass productions, aluminum-based composites, squeeze casting, it is automobile components such as cylinder, piston, suitable for all kinds of reinforcements. Whereas stair casting talks about, as I said it is most appropriate for the particulate type. It is not that suitable for the fiber or the disc. So these are the few comparisons which we have when we deal with the making of the metal matrix materials in liquid phase. A similar kind of what you call comparison we can have with what you call when we deal with Solid state, powder metallurgy is there, diffusion bonding is there, ultrasonic assisted casting is there. Okay. So I think you get a better idea that when basically we made only what you call two criteria. One is the cost and one is the application. So this is a comparison of what you call various methods. A conclusion, what why I made it conclusion here, because of various reasons we researchers prefer stair casting. These 4 points are nothing but they are all going in favor of the what you call stair casting. So what you call normally what happens is that because of limited availability of the equipments, other things, see we normally go for the what you call stair casting. Okay. So these are the few conclusions which I made it on my comparison between the different fabrication methods. So now we try to understand what are the challenges and limitations of the what you call fabrication things. Again, we subclassified them in different categories: manufacturing, material, practical, like that. So in manufacturing issues, we talk about the process complexities and cost consideration. Apart from there are others are there, but I have taken it for only two. We talk about the what we call it as a process complexity. So temperature control is one of the major issues which we deal with. Okay. So one a small example we talked about it, what you call a metal matrix we are having between aluminum and silicon carbide composites. Maintaining metal temperature between is a critical one. Okay. So this is what you call a challenge. It's a very one of the challenges are there. We should maintain that temperature, and at that time only we should carry out the addition of the reinforcement material and other things. Okay. So it all say that one what a fluctuation of a 15 per degree centigrade can lead to the degradation of or poor wetting. Wetting is one of the major issues when we deal with the stair casting. So this is one of the process capability. The second one is distribution control. Okay. So again, it deals upon what you call steer speed. Okay, we use normally a mechanical steering which is rotating it. Okay, that speed of that one has also become one of the crucial points for our what you call stair casting process. Tooling. Tooling is also become one of the areas or one of the challenges or the issues we deal with what you call when we deal with the matrix materials. Cost consideration is also one more there. Okay. So normally if you compare what you call of course it is again in terms of dollars. So you'll find that one getting silicon carbide 99% is a costlier affair compared to the conventional materials. So equipment is also when we go for powder metallurgy, when you go for other things or vacuum type, so naturally the cost will keeps on increasing. So these are the some challenges which we faced when we deal with the what you call manufacturing of the composite materials, in particular metal matrix materials. So testing is also a one more what you call costlier one. Okay. Your normal test mechanical normally our researchers will carry out mechanical property test and other things. But basically, if you wanted to get a little more detail about the distribution, how composite material is affecting, so we need to have a little more sophisticated inspection methods. So it will be little costlier. So solution to the major challenges. So manufacturing solutions, again, we have a process control solution. Advanced temperature controller, we should make use of it. So implementation of a closed loop temperature control system is very important because we need 2 or 3 thermocouples. We need 2 or 3 thermocouples to measure the temperature. One is measuring the molten temperature of a matrix material. Sometimes we need to preheat the reinforced material and we have to add it. And plus we need one more thermocouple to carry when we pour it into the mold cavity. So an advanced temperature controller will give you a better what you call control over the process. That is what I just mentioned. Use of multiple thermocouples for zone monitoring, that you can do it. Further, nowadays everywhere computers are there, and everywhere computers are controlled are there, because display is easy and operation is also there easy. So that is another one we can go for it. Infrared thermal imaging for real-time monitoring, that also we can make use of it. So distribution control systems solutions, ultrasonic assisted steering technology, we can make use of it. So normally we go for what we call it as a mechanical steering. So instead of mechanical steering, a ultrasonic assisted steering technology will give you a much more uniform distribution of reinforcement material in the matrix material. Electromagnetic, another way. Electromagnetic means what? Again, the aluminum or other metals are all what you call they are all, we can pass the current and we can deal with the electromagnetic attraction in order to get this steering action. So optimized what you call design. If you go for the mechanical, you can have a impeller type of the designer. Okay, most of the I think you might have seen a better kind of steering when we deal with this painting. I just want to go to my participants. आप लोग अगर घर में कहीं पेंटिंग वगैरह किए तो, या what you call wall पुट्टी वगैरह आप लोग लगाए तो, the people will bring a particular small steering machine. Anyone has seen that one? To mix up this wall पुट्टी लगाने का जो रहता ना, or in paint. Any participants has seen that one?
Sir, it's
Steering
like a metallic plate. Are you talking about?
Not exactly metallic plate. There will be a impeller type of design is there. जो मोटर रहता, मोटर के नीचे जो है ना, वो स्टीयरिंग के लिए, पुट्टी के लिए a twisted type of blade is there. अगर नहीं है तो देख लीजिए. That is the one of the good examples what I can share with you for better steering. वो लोग वॉल पुट्टी मिक्स कप करने के लिए हाथ से नहीं कर सकते वो. So because we need what you call semi solid बनाना पड़ता है उसको, हाथ से मिक्स अप नहीं कर सकते. So normally they will bring up. Okay, it has become very portable one. So that how it enhances the efficiency of application of the wall putty. Similar way, my change in steering design will create so many things. So cost reductions, we can think of it. So these are the few what you call other solutions which we suggest in order to reduction of the cost. So we have seen what you call manufacturing issues we have seen, and we try to find out the solution. On the same lines, now I will deal with challenges and limitations in material challenges. What are the material challenges? Interface reactions, reinforcement distribution, thermal mismatch, property consistency. But I'm going to deal with only two things. Interface reactions. Okay. Again, we talked about the controlling of the temperature. So the temperature has got a impact on interface. If we talk about the titanium with carbon, formation of brittle titanium carbide layer during the processing above 800 degrees, leading to a premature failure. So these are the few challenges which we face it in when we deal with what we call it as our formation of metal matrix. This is one example. This is one example. This is one example. So these are all the questions with the interface, because matrix, reinforcement and interface, These are the three things together a composite material will form. So these are the what you call reinforcement distribution. One of the issue with clustering of the particles. Okay, so but we wanted to have a equal distribution, but challenge is that it will cluster. This all it will become more what you call troublesome when we deal with this nanoparticles. Okay, when we deal with the nanoparticles, this clustering is major issue which we deal with when we prepare the metal matrix material using the stir casting processes. Okay, so another is aluminum and boron carbide particles settle within 5 minutes without continuous stirring. This is one of the challenges we face with the reinforcement distribution. Orientation issues, another challenge what we face with the what you call your making in metal matrices. So we go for the solutions. So these are the few solutions which researchers try to give it. Okay, so you put a coating of exactly I'm not remembering this one what the material is there, so it will improve the wettability. Okay, it will improve the wettability. So for this wettability is concerned, I wanted to give a small example. So normally everybody we shave, yes, हम लोग शेव करते हैं, है नहीं? Okay. शेव करने के लिए we apply what you call foam बोलो, we apply foam apply करते हैं और पेस्ट अप्लाई करते हैं, जेल अप्लाई करते हैं. I'm audible, dear participants?
Yes, sir. You are perfectly audible, sir.
Yes, yes. Similarly, बालों के लिए लगाने के लिए we use hair oils, we use gel. Okay. What is the big advantage when we apply what you call a oil with the gel? Probably most popular gel is set wet gel, something is there. I think it's very popular. So what is the advantage of gel? Myself, I experienced that gel. पहले मैं क्या बोलते हैं शेविंग यूजिंग द ट्यूब करके इस्तेमाल करता, पेस्ट आता था, पेस्ट लगा के ब्रश I used to put the brush to create a foam on the face, then I used to shave it. So later जब जेल वगैरह आए, जेल लगाने लगे, अभी तो फोम आता है. जेल का क्या what is the big advantage? इवन सेट वेट जेल बोलो या कोई भी हेयर के लिए अगर कुछ स्टाइलिंग करना है तो पीपल यूज द जेल. जेल इज नथिंग बट एनीथिंग इन द फॉर्म ऑफ जेल, it increases its wettability. I'm clear, my dear what you call participants? Yes, I hope you might have experienced this one. एक बार तेल लगा के देखिए, एक बार जेल लगा के देखिए. So gel, anything in the form of a gel, it will increase the wettability. So this
It reduces the friction, sir.
Yeah, yes. Not exactly friction. If it comes to the hair को अच्छी तरह चिपक जाता है वो. सेट वेट का तुम अगर एडवर्टाइजमेंट देंगे तो यंग बॉय विथ ऐसे पूरे बाल खड़े हुए जैसा है. Okay, so we can make any kind of styling with the gel, that one. So wettability is more. So friction is true in case of shaving, but जब तक hair तक का है, it is more wettability. Even in shaving also, gel will perfectly wet with the small hairs which are grown on the face. Face के ऊपर जो बाल रहते हैं ना, उसके deep तक जल जाता. normally paste नहीं जाता. Okay. So this is
Yes,
how
yes.
what you call a improvement of the what I try to tell you that one. What do you mean by the wettability, or how it affects the performance? Okay, हम लोग जल लगाना, फोम लगाना, ये कैसा हमारा जो परफॉर्मेंस है, शेविंग परफॉर्मेंस है या स्टाइलिंग ऑफ द एयर कैसा ज्यादा बढ़ा था ना, वैसे ही वेटेबिलिटी विल improve the what you call properties of the metal matrix materials. Okay,
Ritesh
matrix
Mulve,
modif-
sir. Sir,
Yes,
sorry to
yes.
interrupt you. Ritesh,
No,
sir,
no.
Sir,
you wanted to ask the question?
yeah. Sir was asked something. I think, Vishaldatt sir, it may be something that is connected to surface tension and all. That is bringing down the surface tension
one?
forces so that it can wet.
Yes.
If I am,
Yes, when,
yeah,
when you get into the mechanics of wettability, when we deep get into the mechanics of the wettability, of course, surface tension and other issues will come out. But my point
Yes,
is
sir.
that one, to realize that one, what do you mean by wettability? So to taking examples. Okay, thank you for
Yes,
adding to my explanation.
Right, sir.
Is anybody wanted to add something more to that? You are most welcome, not an issue. Okay. If no additions are there, then I will continue with my presentation. So this is the matrix modifications which we talk about it. These are the some challenges. Okay. So when it comes to the powder metallurgy, these are the some issues. Some issues are with the liquid processing solutions are there. So these are the challenges normally we face when we try to make out a metal matrix composites. Okay. So just try to find out what solutions we may think of it. Let me check 1 minute. Okay. Check 1 second.
You got the
Yes.
काय कर तू
So I covered the what you call challenges in material challenges. Then I provided you the material solutions. Okay. The third part, I'm going to deal with the challenges with practical limitations. So these are the few what you call practical limitations which are listed here. So machining difficulty. Machining tool wear is an example. Okay. So this is the one of the difficulties. We get it. Why I'm talking about this machinability, everything. After making the matrix, see, synthesis of metal matrix is not stopped there. Finally, my metal matrix has to perform. If it has to perform, is definitely it has to undergo machining. Either it may be at the primary stage manufacturing process, or it may be secondary one, or it may be achieving the dimensional accuracies. You need to go through the machining one. So that's why the machining difficulties becomes a major issue in what you call metal matrix. So tool wear is a problem. Okay. So because metal matrix, when we add up the reinforced material, we are improving the mechanical properties. Basically, we are improving its hardness. So in order to get a better wear. When it becomes hard, so naturally a question will rise of the tool wear. Easily, we should have a tool which can withstand that what you call hardness, and there should be less wear. So tool wear is an difficulty, and surface finish is another one. See, unless and until we achieve the required surface finish, the said functionality cannot be achieved. When said functionality cannot be achieved, then performance will be less. So very interesting thing is that in some cases we need a rough surface. In some cases we need a very smooth surface. When as far as brakes and other things are concerned, we wanted to have a more friction so that my braking system can work efficiently. I wanted to have a not so smooth surface finish. When it comes to any rotating part or moving part is there, I wanted to have a better surface finish. So this is how the surface finish will have an impact on both good surface finish and sometimes not good so surface finish. Okay, so joining complications are also there. Okay, because joining is another way which is a secondary manufacturing helping in converting the metal matrix into the products. So that's what you call some what you call challenges I listed here. Okay, so let's try to look at the what we call it as a solutions for that, practical solutions. So tool technology is there. So PCD, polycrystalline diamond tools, we can make use of. Cryogenic cooling techniques, we can make use of it. Optical cutting parameters, we can change. Most of the researchers are doing all optical, trying to find out a optimal cutting parameters. So use of hybrid machining processes, process optimization, we can talk about it. Implementation of adaptive control system, minimum MQL we can make use of it. Ultrasonic assisted machining we can go for it. Laser assisted machining for hard materials we can go. Even we can go for advanced welding techniques. So alternative joining methods we can think of it. So these are the some solutions which we try to get out for the practical solutions which we face in what you call dealing with metal matrices. Some industry specific examples we try to take it. Okay, so these are the few applications where we make use of what you call metal matrices. I'm not going to go much more about it because most of the people are aware of it, where our metal matrices are there. So successful implementation, I wanted to talk about it. So this is a case study of aerospace engine components I'm talking about it. So company is Rolls-Royce. The component is turbine engine fan exit guide vanes. The solution implemented is titanium metal matrix with silicon carbide fibers. The what results we got it? 40% weight reduction compared to the nickel alloys, which were earlier used for that purpose. Surface temperature has increased to 600 degrees centigrade. Most of the time we will be dealing with these in gas turbines, which are used in aeroplanes and other things. So component life extended by 25%. See what a wonderful achievement we have it. Because when we deal with these turbine blades or gas turbine blades, it's a big issue. So very wonderful results we got it. 30% cost has been reduced. So these are the few results. What strategy they have developed or they have used? Developed a property fiber coating technology, implemented vacuum hot pressing with precise temperature controller, and created automated quality control system. So these are the what you call a case study of implementation of what you call challenges and solutions in order to achieve a better performance of the materials. So let me go with one more example of case study 2, that is automotive brake system. I'm audible now, my participants. I'm audible and my PPT is visible to
Yes,
everyone.
yes.
Yes, sir.
Yes.
Okay. So second case is the company is Toyota. Component is brake rotors, aluminum and aluminum based metal matrix. Solution implemented is titanium metal matrix with silicon carbide fibers. So what results we got it? 60% weight reduction versus cast iron. Earlier cast irons were used. It is replaced with composite. Wear resistance improves by 45%. Wonderful. Production yield increased from 70 to 92%. Cost reduction 35% through process optimization. Key innovations, what we got it? This is the one K2 TIFR coating on silicon carbide particles, which I gave it as a solution. This is a what you call invention from Toyota company. Two-stage steering process, inline ultrasonic testing. On this side, I just showing you that one, how these are made, Hard particles like silicon carbide, aluminum oxide, boron oxide added to aluminum matrix. This is a known thing. So these are the benefits. So just to add to it, so this is a case study, and this another third one is industrial manufacturing. Sandvik Coronomanta is a company. Component is cutting tools. Solution implemented is functionally graded tungsten carbide cobalt metal matrix. Almost everybody knows that nowadays all carbide tools are made out of composite. Tool life increased by 200%. Cutting speed improved by 40%. Manufacturing cost reduced by 25%. So defect ratio is below 0. Implementation. Grade composition control, advanced sintering technology. So this sintering technology is very important. Okay. So this sintering gives a perfect binding between the cobalt and this tungsten carbide. Okay. So these are some successful implementation of challenges and solutions of what we call it as our metal matrix processes. This is my last slide. That is my topic was pro and cons of fabrication of metal matrix. So let me sum up the things in 4 to 5 points. First one is enhanced mechanical properties. So this is a known thing for us. That's why we go for the composite material. So less weight, better properties, less cost, more durable. These are always the dream of a mechanical engineer. So hence we can achieve it. The second thing is tailored properties. So tailored properties also. So tailored properties, the another big advantage. Then we have a
Participants, please mute your mic. Please, sir, proceed.
yes, high temperature performances are there. Good dimensional stability is there. These are the few pros, and these few are the some cons. High production cost, limited ductility, challenges in achieving uniform distribution, wettability issues, and processing complexity. So these are my references. Thank you. I'm giving out some time for some 5 minutes. I think it is still left out. We can go for the interaction.
Participant
it's
can
a
ask a
request.
question.
Yes.
Santosh is there. Santosh Madki is there in this one session.
He was there for some time, sir.
Okay.
Currently, no, sir. He's not.
Okay. Harish is there. Harish Gudkar, have you joined? Harish?
Shall I call him? Shall I call him?
No. I think my voice will be reaching him.
Yeah, it is reaching. Shall I call Santosh?
Not necessary. Not necessary. Not.
Okay.
Just I wanted
You were one more.
Yes, one of the challenges which was faced by the Santosh Madki was with the application of pressure in achieving the squeeze casting. He carried out the process with what we call it as a less pressure. Okay, so we were very much skeptical whether with that pressure we will able to get a better microstructure or better distribution of the reinforcement material. To surprise to us, it was a good one. And that too, we get a very good feedback from person where my Santosh Madki has carried out his machining. Okay, so these are the things. If Santosh Madki would have, he would have more elaborated the things. So I think with this, I conclude my session.
Student was there, no, sir? One more. You told that.
One more. Harish. Probably I check it out.
I will check, sir.
Just
Harish.
I will check it out whether he is available or not. I will check
No,
it
sir.
out.
Harish, no anyone. Harish is there.
So probably he is also maybe what you call busy. Okay, it's not because he worked on a hybrid composite material. So he has also he faced some challenges and he overcome. So just I wanted to have a what we call it as a first-hand experience with the what you call participants. So this all
Sir,
this
there
is
are
all from my side.
yes, sir.
I
There
think
are two
sir,
questions from Sachin Bhosle, sir.
yes.
The first question is: Are complex geometrical shapes are difficult with powder metallurgy, but easy with squeeze casting? This is his first question.
Pardon.
Are
It is in
are
the chat box.
yeah, it's in the chat box. The first question
Let me go.
is
Okay.
yes.
Our complex geometrical shapes are difficult with powder metallurgy but easy with squeeze casting. Answer is yes. Somebody, Sachin, is he himself say basically whether it is a squeeze casting or whether a petrology, we need a die. Okay, so cost wise and technology wise, squeeze casting is easy, but better dimensional accuracies you will achieve it with the powder metallurgy, and wastage will not be there in case of powder metallurgy. If a choice is given, complex shapes can be done better with powder metallurgy compared to the squeeze casting. This is my answer.
And his second question is: Which different characterization techniques are used for MMC to check quality of finished products?
There are many ways are there nowadays. The new way of characterizations are also there. If I get time, some other time, I will throw a little more light on that one.
Ritesh
So,
Mulge, sir, do you wanted to ask the question? You have raised the hand. Ritesh Mulge, sir.
No, it was the previous one, sir.
Okay,
Sir had.
fine.
Okay. Thank you, sir.
Yes, participants, anyone wanted to ask the question, they can directly unmute the mic and ask the question.
So how many persons are doing research in this participant? I could see 127. How many of are pursuing? See, dear participant, kindly interact. Basically, it is a program for us only, faculty development, what you call development program. Development can only takes place with interaction. When we interact it, many misconceptions will go away. Okay, because we are all teachers. Okay, somebody said that they are working on nano composites. Very good.
So anyone is going to ask any question more?
Can I know, Uma Maheshwari, have you made any composites? Your research work is at the initial stage or it is in the advanced stage?
Madam, you can unmute and speak. Hello? Uma Maheshwari, madam? If you want to ask the question, you can unmute and ask.
And I wanted her to share her own experience, because see that one, everybody will be doing their researches, everybody will get a different kind of challenges. Okay, so a interaction or the sharing of their challenges with the other faculty members will be advantageous. And remember, all my dear faculties and my researchers, be vocal about the things on which you are working. Okay, normally we don't want to open up thinking that मेरा पोल खुल जाएगा, वैसा कुछ नहीं है. Okay, so everybody will be what you call in the same one. Okay, Anant Chipte willing to do in ceramic composites. Very good. So Uma Maheshwari, you are not audible.
Madam, you make your mic unmute. She may be having any problem.
Okay.
Maybe network.
It will be so many
Maybe
other
network.
troubles.
Yeah.
Luckily, there won't be much technical difficulties while my presentation, I think so.
No problem. No, sir. Exactly. So smoothly your presentation has took place, sir. So I would like to.
So how much I justified, I don't know, because I got little less time to
No, sir.
make a preparation.
Exactly whatever the topics we have selected. So you have elaborately given the information. So that is very nice presentation, sir.
Thank you.
Excuse me, sir.
Yeah.
Yes, please.
Hello. May I ask something?
Yes, please.
Sir, actually, I'm planning for my research in this same field of materials.
Yes.
Currently, I'm teaching the same subject of mechanical engineering materials in some polytechnic college.
Okay.
I just want to know that is there any way or new idea to make such research within the reach of a common man? Means what I'm asking to you, sir. There is so much cost required for raw material, for experimentation, for any other type of this process.
Yes.
So I just want to know that is it practically possible to do a research within the reach of a common man?
Why you are talking about a common man means you ask for a common teacher. That will be more appropriate word.
Okay, like that. It's like a common teacher.
Because common man is not interested in research, man. Only teachers are there.
Okay.
Vaibhav Vaidya.
Right, sir.
Yes. All faculties who are working in private engineering colleges,
Yeah.
everybody is facing the same problem, and everybody is thinking like that only. They
Yeah.
are also thinking that how to come out it. But I will tell you, whatever researchers have done in private colleges, everybody has overcome the difficulty what has come in your mind.
Okay.
In my opinion, no. A common teacher very comfortably he can carry out the research work in materials. If you would have asked this question a decade back or say 7-8 years back, I would have said it difficult.
Okay.
Right now, there are many colleges are there and there are many industries are there where you can go and prepare your composites. Okay. Even
Okay.
you can visit a website, what we call it as a STEM. Okay, STEM is a website where it brings a researchers and the facilitators. It means it's a common platform where all colleges are posting their facilities there. You can search in the STEM website, so you will get anywhere which college where that facility is there. Easily you can do. 100% you can do a good research in what you call material. Only thing is that you have to be prepared. And my very one small what you call tagline for all researchers is that for research, apart from researcher, nobody stops you. Okay, you got Vaibhav?
Yes, sir. Yes, sir.
If you are ready, you can achieve it. Not an issue.
Thank you.
You are from where, Vaibhav? You are from basically?
I'm from Parbhani, Maharashtra state.
Yes. No, not an issue. Santosh Madki is the best one who is working in, who is the coordinator for the FDP. You can contact him. He will tell you how to come out with all these challenges, what you are saying. Okay.
Yes, sir, definitely. Thank you, sir.
Ritesh Mulge, are you going to ask any question?
No, sir. Mine is totally different. I am into alternative fuel. I'm just.
Not an issue, Mr. Ritesh. You are in alternative fuel. To make use of this alternative fuel, you need composite cylinders and pistons.
That is it, sir. Right, sir. Right, sir. Right,
Yes.
sir. I got it.
Unless we fabricate you the proper cylinder and piston, your alternative fuel will damage my piston and cylinder. Very much it is correct. If you have any question, you can ask. If not, thank you.
Right.
Hello, good evening, sir.
Yes.
Hello, sir. Actually, I want to ask one thing that I was giving my PhD interview first time.
Okay.
Actually, my topic was vibration analysis by using design and optimization by using different materials for
Okay.
four-stroke multi-cylinder engine. Everyone has been used for that four-stroke single-cylinder engine. Then my question is that I was using a different materials for the crankshaft. The now material is cast iron. If I
Okay.
use the composite material for my research work, I'm little bit confused whether it will be run successful or not. It was my the first experience while giving the interview of PhD. Unfortunately, I not selected, but I'm trying to look research in that only for the vibration analysis of crankshaft using by four-stroke cylinder in multi-cylinder engine. Everyone is using there is a cast iron as a crankshaft
Yes,
material.
yes. No, no, no,
And
no, 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 I got your question. Okay.
yes,
So you try to say that one. You wanted to have a experimentation with composite material
yes,
uh, as a material for crankshaft.
yes.
So see, when we call it as a research, always research is not. It is in two directions. One, it can be done, but it cannot be done. Both results are very much helpful for us. So I recommend you to have a little what you call survey on. Is there any previously anybody has tried to make use of this composite material? You take out a survey on that one. If somebody has done it, look at their challenges, try to remove those challenges and try it in a new way. This is my suggestion. If you doesn't find any person done it in your survey, I recommend you what you call fully to go with this one. At least you can say that one composite material never work for the crank. That conclusion you can come out.
Okay, sir.
You
Thank
got
you
you
so
got
much.
my point.
Yes.
So you may be the pioneer in that one.
Yes.
Okay,
Okay.
definitely when we talk about the composites, definitely vibrations will be get reduced.
Okay.
There is no doubt about it.
Thank you so much, sir. Thank you so much.
Yes. Go ahead. And one more thing, one more thing I would like to share with Akshay Kajre.
Yes.
There was an interview of Narayan Murthy in CNB 18.
Okay, sir.
Okay. So in that interview, he said that one, China is doing lot of research. And now also, if you go through the what you call your Google search, you will find any topic, anything, you will find a n number of papers of China. Quoting this, Narayan Murthy said that one invention of Einstein has come to use after 90 years, 90 years, which is reduced a 80 miles distance between the two satellites. The underlying point is that one, any kind of research may come into the picture at any time. So never stop your imagination, your innovation in conducting the research.
Okay, sir.
Now
Thank you
it's
so
clear,
much.
Akshay sir.
Yes, thank you so much, sir. Thank you
With
so much.
big heart, you go with the
Yes,
research.
yes, sir.
Yes.
So
Thank you, Uma Maheshwari,
thank,
madam, giving me a good feedback.
thank you, sir.
Thank you.
Very
Thank
nice
you.
session and
Thank you,
very
sir.
informative. As Uma Maheshwari madam has quoted here, that for the upcoming researchers as well for current researchers, your guidance is very important. They will definitely use this, and let's end this session, as next session is scheduled at 7:30 and the resource person is waiting in the lobby. So thank you on the behalf of our management and the AICT ATAL. I would like to thank Dr. Kohir sir, and also I thank co-coordinator Dr. Santosh Madki, who is a student, PhD student of Kohir sir, and he has invited Kohir sir for this FDP, and his guidance has really useful for all the participants. So once again, I thank Kohir sir for accepting and delivering such a nice presentation. Thank you very much, sir.
Thank you. Thank you, sir. Thank you. Thank you.
So
I
shall
think I
we?
will.
Yeah,
I
sir.
will leave the meeting. Okay.
No, no problem, sir. Thank you, sir. Thank
Okay.
you.
Thank you. Thank you. Thank you.
Okay, sir. Shelar, sir, to stop the recording.
Just minutes, sir. Just yeah.
Yeah. Participants, don't leave the meeting. Already second session's time is